write a chemical formula? First of all, what is chemical formula? About chemical formula, we discussed in the last video, sir, no? So let's define again. So the shorthand representation of molecule or a compound using symbols and subscript numbers is called as a chemical formula. Sir, we are representing a molecule. First of all, how does that molecule form? That we are going to discuss in this video. Even before that video, we discussed about ions. Yes or no? What are ions, students? Ions are the charged particles. They are called as ions. How many types are there? Cations and anions. Cations are the positively charged particles. Anions are the negatively charged particles. So why I am talking about ions? Because we are going to write the formula from these ions only. From these ions only. You already know cations and anions, students. We have one more subdivision of cations and anions based on the valency of the charge. Valency of the charge means you all know, you already know the examples, yes or no? For example, some cations have +1 charge, some ions have +2 charge, some have +3. Depends upon the number of electrons they lost. Yes or no? Do all elements lose 1 electron only? No. Do all elements lose 2 electrons? No. Similarly for anions also, some have -1 charge, some have -2 charge, some have -3. So based on this valency of the charge, we have types of ions, and from these ions only we are going to write the chemical formula. So that's what we discussed in this video. First of all, let's see these ions. So students, based on the valency of the charge, these are the types of cations and these are the types of anions. Look at the first one, monovalent positive ions, also called as monovalent electropositive ions. What's the meaning? Monovalent means they all have the charge of +1. They are cations, monovalent positive, +1 charge. Look at the examples, H+, Na+, K+, ammonium ion, NH4+. What is the common thing in all these examples? They all have +1 charge. Yes sir, and they comes under monovalent or univalent, both are same. And look at here, bivalent positive ions. What's the meaning of bivalent? They all have +2 charge. And magnesium ion, calcium ion, Fe+2, ferrous ion, yes or no? +2 charge. So bivalent or divalent, they also be called as divalent also, both are same. Next, trivalent positive ions, aluminium ion, ferric ion, Fe+3. So all these ions have +3. Not only +3 students, even tetravalent ions also there, pentavalent also there. So main examples are mono, bi and tri. So we'll focus on these 3 types. Similarly, in the case of anions, which are the negatively charged particles, we also have the same monovalent, bivalent and trivalent. Monovalent negative ion this time, or monovalent electronegative ions. Look at the examples. Fluoride, what is the charge? -1. Chloride, Cl -1. Hydroxide, OH -1. Yes or no? All they have -1 charge or not? So monovalent negative or electronegative. Bivalent or divalent negative. Look at the examples. Oxide, sulfide and sulfate. And trivalent negative. What are the examples? Phosphide, P-3, phosphate, PO4 -3. So students, what is the common thing? -3 charge. What's the meaning of -3 charge? They gained 2 they gained 3 electrons. Yes sir. What's the meaning of bivalent negative? They gained 2 electrons. What's the meaning of monovalent negative? They gained 1 electron. Similarly, what are the meanings of mono, bi, tri positive ions? They lost 1, 2 and 3 electrons respectively. These are some of the examples of the students. You can see on the screen the remaining examples, the list of all the cations as well as the list of all the anions. So students, answer by looking at these ions, answer, do all these ions, do they exist in the nature freely? Freely means independently. For example, let us take sodium ion, Na+. Yes or no? Does this sodium ion, does it exist in the nature as Na+ ion? Is it freely moving like Na+ ion? Answer, yes or no? Oxide ion, does it exist in the nature as oxide ion, like only O-2, independent oxide ion? Yes or no? The answer is no. Why? Because students, these ions, they already lost an electron or they gained an electron, they carry a charge, whether it is a positive or negative. Yes or no? If they have a charge, they are highly reactive. If they have a positive charge, they always show attraction towards a negative. If they have a negative charge, they always show attraction towards a positive. That is reactivity. Yes or no? So the answer is, these ions do not exist independently. Sir, why? Why? Because they have a charge, and this charge is the reason for the reactivity. Then what happens? You know what happens, students? They always exist in the combined forms only. how do they combine, why do they combine, that we'll discuss in this video. Students, combined form means, do positive positive combine? No. Do negative negative combine? No. Why? Because positive positive repel with each other, negative negative repel with each other, positive combines with negative. Why it is combining? Why positive is combining with negative? Why? Because students, the main point, listen, the reason is they want to neutralize the charge which they have. What's the reason? They want to neutralize the charge. For example, +1 is there. If it combines with another +1, does the charge gets neutralized? +1 equal to is 0? No. +2. First of all, do positive positives combine? No. Similarly, do negative negatives combine? No. Then what will happen? Positives always combines with negative. Why they're combining? In order to neutralize the charges. Remember, in order to neutralize. How, sir? How to neutralize? +1 is there. How +1 equal to 0? -1. +1 -1 equal to 0. So, positive ion combines with a negative ion or not? Why? In order to neutralize the charges. Sodium ion, Na+, chloride ion, Cl-. Sodium ion, chloride ion independently exist? No, they exist as sodium chloride. Is there any charge on sodium chloride? No. Got the clarity? Let's see an example, students. For example, what is sodium ion? Na+. What I am saying? These charged ions, they do not exist independently. Then what I said? How do they exist? Always in the combined form. Combined form means how they combine? They always combines with same charge or opposite charge? Opposite charge only. Okay, this is sodium ion. Next, say what is chloride ion? Cl-1. Sir, this is Na+1. That is Cl-1. +1 -1 equal to how much? 0. Yes or no? So one sodium ion combines with how many chlorides? One chloride only. +1 -1, students. So sodium ion combines with chloride ion and it exists as sodium chloride. Sodium ion does not exist freely. Chloride ion also doesn't exist freely. Then how do they exist? They combine and they exist as sodium chloride. Sir, we all know sodium chloride, which is the cooking, for cooking purpose we use the common salt or the table salt, right? So that is what. Do you find any charge on this molecule? No. There is no charge on this compound. Why? Why we are not representing the charges? Why? Because they are already neutralized. Yes or no? +1 -1. So now answer, why all these ions are combining? First of all, do these ions exist independently? No. Why they are combining? In order to neutralize the charge which they carry. Sir, it is +1 only. If there is a +2, that these are the examples which we'll discuss. Okay, students, clear? Got the clarity? +1 -1. They need to combine in what ratio? 1:1 ratio only. Yes sir, no, +1 -1 equal to 0. One sodium ion can neutralize one chloride ion only. Got the clarity? Let's see other examples. So instead of sodium, if we have a magnesium ion, Mg+2, students. Now answer, how do they combine? Can we write the formula like MgCl? Can it be neutralized in this ratio? No. Why? Because what is the charge on magnesium? +2. What is the charge on chloride? -1 only. Yes or no? How +2 can be neutralized? By a -2. Yes or no? +2 -2 equal to 0, right? But how much charge is here? -1 only. Is it possible to change the charge from -1 to -2? No. We cannot change the charge. Why? Because chlorine can gain 1 electron only according to its configuration. We cannot make it into 2. Yes or no? But how to write? What we can do? So, you know what happens? Magnesium ion combines with 2 chlorines. Right? One chloride, it is -1. If it combines with one more chloride, then how much, students? -1 -1, how much? -2 together. Negative charge. -2 + 2 equal to 0. So then what is the formula? The formula is MgCl2. That's it. What is the meaning of MgCl2? There is one magnesium ion and there are 2 chlorides ion. 2 chloride ions. Yes or no? That's how it is neutralized. Is there any charge here? No. Understood? Got the clarity? Why some elements are combining in 1:1 ratio? Why some are combining in 1:2 ratio? Why some are combining in 1:3 ratio? It all depends upon the charge on the particular ion as well as the valency of the element. Ultimately, why they are combining these ions, opposite ions? In order to neutralize the charge which they carry. Understood? Let's see another example. In case of magnesium, instead of magnesium, students, if we have aluminium, this time you have to answer. What is aluminium ion? Al plus 3. Now what is the charge on aluminium? Plus 3 is the charge. Answer, to neutralize plus 3, opposite should be minus 3. Yes or no? But look at chloride, minus 1 only. Can we change minus 1 to minus 3? No, I already have said, right? Instead, what we can do, we are not doing it. That's how aluminium exists in the nature. We're just simply studying it. Okay. So aluminium need to combine with how many chlorides? You already got an answer. Yes or no? Aluminium combines with 3 chlorides. So what is the formula? AlCl3. What is the meaning of AlCl3? There is one aluminium ion. How many chlorides are there? There are 3 chlorides. Cl minus 1, Cl minus 1, Cl minus 1. Minus 1, minus 1, minus 1. How much, students? Minus 3 altogether, the charge. And plus 3. 0 or not? Is there any charge on this compound? Understood? Got the clarity? NaCl 1:1 ratio only. Why? Because plus 1 minus 1. MgCl to 1:2 ratio. Why? Because on magnesium there is plus 2 charge, chloride minus 1. Aluminium chloride 1:3 ratio. Why? Because the charge is differing. Plus 3 charge this time. So based on the charges, we have different ratios of formulas for different elements. Ultimately, why they are combining? In order to neutralize the charges. Students, got the clarity? Neutralize the charges. So there is one shortcut technique, students. That technique is called crisscross method. First of all, you have to remember the concept. What is the concept? Neutralizing the charge. That's why they are combining. Yes or no? But to write the formula, we have a technique. Simply we can write. That technique is called as crisscross technique. You can see the formula of AlCl3, and you can see the charges here. What is the charge here? On aluminium, plus 3. 3 is the charge number. Okay, plus 3 is the charge. The charge number is 3. This charge number will become subscript number of the opposite ion. Look at here, 3. And look at what is the opposite ion charge number? 1. This number will become subscript number of the opposite aluminium ion. Look at here, aluminium. Of course, 1 we don't represent it. So that's it. That's it. This is a crisscross technique. Let us see once again the previous examples which we discussed. Mg plus 2, magnesium ion, Cl minus 1. Now say the formula. What is the formula? According to the crisscross technique, Mg, what is the charge number on chloride? 1 only, so we don't write 1 in general. Cl, what is the charge number on magnesium? 2. It will become subscript number of the opposite ion. Same formula we got. Yes or no? This is crisscross technique. Sodium chloride. Students, sodium chloride. Na plus Cl minus. According to the crisscross technique, right? What is the charge number? 1. What is the charge number? 1. NaCl directly. 1:1 ratio. Yes or no? In general, we don't represent 1 and 1. Yes or no, students? Got the clarity? This is crisscross technique. This is a shortcut technique, but remember the concept. What is the concept? Neutralization. After remembering the concept only, you have to apply the crisscross technique. Got the clarity, students? Let's see some other examples. So, students, magnesium ion. What is magnesium ion? Mg plus 2. Oxide O minus 2. Okay, what is the formula? Try the formula. What's your answer? According to the neutralization, plus 2 minus 2. Then what ratio they need to combine? 1:1 ratio. Yes or no? 1 magnesium can neutralize 1 oxide ion. Plus 2 minus 2. Now students, 1 magnesium can neutralize 1 oxide. So what's the formula? MgO is the formula. So here some students have done. Sir, according to the crisscross technique, you said the charge numbers, na? Correct. So do you think the formula is Mg2O2? Absolutely wrong. You have to remember one point, student, that is, when you're writing according to the crisscross technique, you have to remember the simplest ratio. The simplest ratio. What is the simplest ratio? What is the charge number? 2 here. What is the charge number? 2 here. 2:2. What is the simplest ratio? 1:1. Yes or no? That is the point you have to remember. If for example, if the charge number is 3, here also 3, what you will write the formula? 3:3 ratio? No, 1:1 ratio, simplest ratio you have to follow. That's it. There are no other rules. Crisscross technique, simplest ratio you have to. That's why I explained the concept also. Don't follow blindly the crisscross technique. Yes or no? 1 magnesium can neutralize 1 oxide or not? Plus 2 minus 2 equal to 0. So MgO. Next example. Aluminium ion, Al plus 3. Nitride ion, N minus 3. Say the formula now. Is it Al3 and 3? No. The formula is Al and aluminium nitride. Yes or no? Why? Shortcut. Why simplest ratio? 3:3. What is the simplest ratio? 1:1. Understood? Got the clarity, students? That's how it is. And according to the neutralization also, plus 3 charge, minus 3 charge. One aluminium can neutralize, one nitride ion. Next example. Aluminium ion and oxide ion. Now say the formula. Say the formula directly according to the crisscross technique. Simplest ratio. What is the simplest ratio? Let's write the first aluminium. What is the charge number of the opposite ion? 2. Right here. Next write oxygen. What is the charge number from oxygen opposite ion? 3. Al2O3. 2:3. What is the simplest ratio? 2:3 only. This is the formula directly. Yes sir, now got the clarity, students? Now see according to the neutralization how this compound is neutralized. Let's check. According to this formula, how many aluminiums are there? 2. Al plus 3. Al plus 3. How many oxides are there? 3. What is the charge on oxide? O minus 2. O minus 2. O minus 2. Let's see how it is neutralized. Plus 3 plus 3. How much, students? Plus 6. Minus 2 minus 2 minus 2. How much, students? Minus 6. Plus 6 minus 2 minus 6 equal to neutralized or not? That's how it is. So if the numbers are like this, then 3 into 2 is 6. 2 into 3 is 6. Common factor. So this is how to write the formula. Once again I am repeating this main point. Do these ions exist in the nature independently? No. Why? Why? Because they carry a charge. They want to neutralize the charge. In the process of neutralization, do they combine with same charge? No. They combine with opposite charge. In what ratio? It depends upon the valency of the element. Yes or no? Depends upon the valency of both the combining element. Plus 1 charge, minus 1 charge. They combine in 1:1 ratio. Plus 2 charge, minus 2 charge. 1:1 ratio. Plus 3 minus 3. Also 1:1 ratio. Plus 2 minus 3. Look at here. So students, next. Sodium ion, which is Na plus, right? Hydroxide ion, OH minus. So what is the formula? According to the crisscross technique or according to the neutralization, you find the answer. Plus 1 minus 1, 1:1 ratio, sir. No, NaOH directly. Sodium hydroxide is the formula. Now, magnesium ion, which is Mg plus 2, and hydroxide ion, which is OH minus, same opposite ion we have taken. Now, what does the formula say? Is it the formula Mg charge number is 1, so 1. OH opposite ion charge number is 2. Is it the correct formula, students? Answer. Is it the correct way of representation? The answer is no. Absolutely no. Why? What's the problem with this representation, students? There is one magnesium, and look at here. This number 2, does it represent for the whole OH radical? No. This number 2 is applied for hydrogen only. Is it correct? Absolutely wrong. Then how to? We have to write this number 2 in such a way that should be applicable for whole hydroxide. Yes or no? Hydroxides are repeating 2 times, right, students? But this number 2 is applied only for hydrogen. Then how to make it? Simply keeping this OH in brackets and writing this number 2. That's it. And how to pronounce it? MgOH taken twice. MgOH taken twice. Magnesium hydroxide. So when we have to keep these radicals in brackets, when the radical is repeated, you have to keep that radical in bracket and you have to write this subscript number. If you know brackets, simply writing the subscript number, what does it mean? This number is not applicable for whole radical. Why? Because a radical, a compound ion is made up of a group of atoms. Yes or no? So to represent the whole group of atoms, you have to keep in brackets. If this here also radical, but are we keeping the OH in brackets? No. Why? Because it is not repeated. Only one OH, right, students? So if the radical is only one time, no need. If it is repeated, you have to write in brackets. Got the clarity? Let's see some other examples. Aluminium ion, Al plus 3. Sulfate ion, SO4 minus 2. Okay, these are the ions. Sir, how to remember? You have to remember the ions, students. You have to practice all these ions and radicals. Okay. So what is the formula? First write Al. What is the opposite charge number? 2. Clear? Next, opposite radical SO4. What is the charge number? 3. Is it correct? What does it mean? 2 aluminiums are there, 1 sulfur is there, 43 oxygens are there. Is it correct? No. Then how to represent? The whole SO4 you have to keep in brackets. Now what does it mean? It means there are 2 aluminiums are there and there are 3 sulfates are there. Yes or no? Minus 2, minus 2, minus 2, minus 6. 2 aluminiums, plus 3, plus 3, plus 6, minus 6, plus 6, 0. Got the clarity? In another case, let's see one more example with the same sulfate. If it is a magnesium ion, which is Mg plus 2 and sulfate SO4 minus 2. So students, say the formula between these two. Mg plus 2 SO4 minus 2. Charge number plus 2, opposite charge number minus 2. They need to combine in what ratio? 1:1 ratio. If it is 1:1 ratio, students, is it the correct representation? Is it the correct representation? The answer is no. Why? Because here the sulfate radical is not repeated, so no need to keep this radical in brackets. Directly you can write MgSO4. That's it. Magnesium sulfate. When you have to write keep the radical in brackets, if the radical is repeated. Understood, students? This is how you can write the chemical formula. Some other examples. What's the formula? You guess the answer. Na plus K plus. First of all, do they combine? Positive ion and positive ion. Not possible. Clear, yes sir? No. Positive combine. No. Negative combine. No. Positive always combines with negative only. Last example, students. This case, I want to give 3 ions. Mg plus 2, OH minus, Cl minus. What is the formula? Students, in this case, does this crisscross technique works? No, that's why I explained neutralization. You already know neutralization, yes, sir. What is neutralization? Number of positive charges should be equal to the number of negative charges. Then only it will form a neutral compound, right? What is the charge on positive ion? Plus 2. It needs negative side. How much should be there? Minus 2. Now look at it. Look at here. OH how much, students? Minus 1. Chloride minus 1. Minus 1 how much? Minus 2. Sir, are they combining? No, they are not combining. They are combining with magnesium. Okay. So what is the formula? Mg OH in brackets Cl. Okay. Magnesium plus 2 charge. Minus 1 together form minus 2 charge. Plus 2 minus 2 neutral. These type of ions are also there. Okay, this is magnesium hydroxide chloride. One doubt. Sir, here hydroxide ion is not repeated. Why you kept in brackets? If these brackets were not kept, students, what does it look like? It looks like magnesium oxide hydrochloric acid or not. So, in the case of 3 radicals, in the case of 3 ions, if they are in the formula, then it's better to keep the radical in brackets. Otherwise, no need. If there are only 2 ion radicals, 2 types of ions only, no need. In the case of 3 types of radicals only, you have to keep the particular radical in brackets. Otherwise, no need. Got the clarity, students? So answer, next example, Na plus K plus SO4 minus 2. Answer, what's the formula? Na plus K plus, do they combine? No, both are combining with sulfate. What is the charge? Plus 1. Here plus 1, plus 1, plus 1, plus 2. Here what is the charge? Minus 2, plus 2, minus 2. Yes or no? Sodium ion is combining with sulfate. Potassium ion also combining with sulfate. Don't think these two are combining. So what is the formula? NaKSO4 sodium potassium sulfate. Can we write this formula using crisscross technique? No, based on neutralization technique. Understood, students? Got the clarity? So that's how it is. If you want to know, see the structure also I'll show you. Sulfate S double bond O, oxygen with minus 1 charge. Here on one side sodium ion is combining, on other side potassium ion is combining. So sodium potassium, are they combining the structure? No, both are combining with sulfate radical. Understood? So these type of ions also exist. So blindly don't follow crisscross technique. So students, in writing the chemical formula, sometimes there is some sort of confusions also. For example, sodium chloride, what is the formula? NaCl. Magnesium chloride, what is the formula? MgCl2. Aluminium chloride, AlCl3. Yes or no? So why not sodium chloride? Why only NaCl? Why not ClNa? Yes or no? Positive, negative, already neutralized. Why MgCl2? Why not Cl2Mg? Why AlCl3? Why not Cl3Al? Understood what I am saying, students? Magnesium oxide, MgO. Why only MgO? Why not OMg? Understood? These are the doubts students will get. So why this? Why not this? The reason is, there is a reason, students, that is given by IUPAC, International Union of Applied Chemistry, gave certain guidelines to write the formula. According to the guidelines, a positive ion should be represented first, followed by negative ion. What is positive ion? Cation. What is negative ion? Anion. What is the reason? There is a reason. The reason is cation's formation takes place by losing electrons. Anionic formation takes place by gaining electrons. Yes or no? Which formation first takes place? Cation or anion? Cation only. For an element to gain electrons, first of all an element should lose electron. Yes or no? Because of that reason, always first cations, then followed by anions. This is the point you have to remember. There are very few examples where we follow the opposite order, like for example in the case of mainly the salts of organic compound, students, like sodium acetate, CH3COONA. This is negative, this is the positive part. So here in this type of examples only, first we represent an anion followed by cation. Why? Because this is an organic compound. This is coming from acetic acid. The formula is CH3COOH. Only the last H is replaced. So for that reason we can't completely change the formula. Understood? Only in the case of organic salts only we represent in the opposite order. Otherwise in general we have to follow a cation first followed by an anion. Understood? Got the clarity?